Hi, what's up guys? This is Ali Reza and today I'm going to show you how to simulate op-amp 741 in LTSpice. So let's open LTSpice here. So as you might already know, if you take a look at the components here and the list of op-amps, there is no 741 op-amps. Okay, so we need to bring the model for 741 op-amp here. So I will start with LM741 op-amp LTSpice, and you can download the model from this Texas Instrument website. It's the PSpice model for 741, but it also works for LTSpice. So if you extract this file, you will get the model for 741 op-amp. Okay, this is the model for the op-amp, and we need to include this model to LTSpice. So what I do is I will copy the location of this file because I need it in LTSpice, and I will use this spice directive and type .include the location of the file, and name of the file is lm741.mod. You also need to include the mod at the end. So I take this and I left click here. So right now I have included the model for LM741 op-amp. So the next thing you need to do is to come to the list of op-amps and look for op-amp 2, which is here. This is just a general basic operational amplifier symbol, and you need to attach a model to this component. So I click OK, and I have the general op-amp component. I left click here, and now I need to connect this component to the model we already included in LTSpice. So if you right click on this component, you see that we need to specify a value for the op-amp. But what is this value? In order to see what is this value, we need to open this file with LTSpice. So if you open that file with LTSpice, you will see that there is this name. This is the name of the model, LM741NS. So I will just copy this name, and I will paste it as a value of the component. Okay, so right now this component is connected to the model, and now you have a 741 operational amplifier, and you can simulate all sorts of circuits with this component. So as an example, let's try and simulate a simple inverter with this op-amp. The first thing we need to do is to provide bias voltages, which are plus VCC and minus VCC. So I will pick a voltage source and put it here, and another one here. I connect these two voltage sources together and make the node in the middle as ground. And right now VCC is this node, and minus VCC is the node down there, is the node here. Let me move this. Okay, so let's put 15 volts here and 15 volts here. So as you see right now, minus VCC is negative 15 volts and VCC is 15 volts. And right now I need to connect this positive port to VCC. I can do it simply by connect this port as VCC and another label for minus VCC. So I will exactly click on the negative port. So right now this port is connected to VCC and this port is connected to minus VCC. And I need another voltage source as input voltage, and I need a resistor here, and I need a feedback resistor here. So, and then by proper wiring I am able to complete the circuit. And we are grounding the positive input of the op-amp. And let's label V out here, okay, and let's put a 5 input voltage, and R1 is going to be 10K and R2 is going to be 20K. So let's try and run a simulation with this circuit. I will choose DC operational point. Okay, as you see, V out is very close to minus 10, and you can verify it by writing a KCL here. So V out is R2 over R1 times 5 with a negative sign, and that is very close to this value. So I hope this was helpful to you, and I see you in the lab.